Okay, question number 5. The diagram shows the trajectory of an electron traveling into a region of uniform magnetic field. Flux density of 2.0 millitesla. So the electron enters a region of magnetic field at 90 degrees. So draw the directions of the force experienced by the electron at points A and B. Okay, now according to the Fleming left-hand rule, so the field is go into the paper. Okay, field is going to the paper. So I have a current that field going to the paper. So I have the current that going back because the direction time is opposing the direction. So I should have a force that act on A is going down. Okay, the force that act on B is also going into it. So you know that this is actually the electron is moving in a circular motion. Okay. B. Explain why the electron described part of the circular path while in the region of the magnetic field. So the radius of curvature of the path of the electron in the magnetic field is 5 cm. Calculate the speed of electrons and explain how the answer in C would change if the electrons describe a path of radius 2.5 cm. So let us solve B first. Okay. So B asks about why is the kind of the part of the circular path or in the region of magnetic field. Okay. So you have to understand that according to the Ref and Fleming rules. Okay. So the field is going into the paper, and this is the motion of electrons. So you know that there is a force that always must be tangential to the motions. Okay, so this is all according to the left-hand Fleming left-hand rule. So sorry, it's not tangential. It should be right angles to the motions of the electrons. Okay, so the explanation is like this. So the force on the electron is at 90 degree to the velocity. So hence the path described by the electron is a circle. Okay, so part C would like to find what is the velocity. Okay, so now this electron is moving into the field. Okay, and this field, the force that act over here will cause this electron to move in a part of circle. So this is a part of circle. So I will know that the force by magnetic field will be equal to the force, or you can say it's a centripetal force, or I will use it's a centripetal force. Okay, so BQV equal to mv squared over r. So I lose one v over here, so I should have v equal to BQR over m. Okay, so B here is 2 millitesla, 2.0 times 10 power negative 3. Okay, so the charge of electron is 1.6 times 10 to the power negative 19. Okay, and the radius is 5 times 10 to the power negative 2. Okay, divided by the mass of the electron is 9.11 times 10 to the power negative 31. So I have a big velocity, a large velocity is 1.676 times 10 to the power 7 meter over second. Okay, now in part D, they ask you to make use of the part C sections. If I half the R to make it into 2.5 cm, so previously R naught is 5 cm. Now my R new is become 2.5 cm. So what happens to my velocity? So according to the previous equation, V equal to BQR over M. Without doing further any calculations, I will know that V proportion to R. So if my R is into half, I know that my V also into R. So my V will be equal to 1.76 times 10 to the power 7 meter over second divided by 2. So I should have 8.8 times 10 to the power 6 meter over second.